The transpose of the cofactor matrix obtained is called the adjoint of a square matrix. Adjoint of A is always equal to, interchange the diagonals, interchange these two diagonal elements. A into adjoint of A is equal to adjoint of A, that is also equal to determinant of A. If two rows and two columns are same, then the value of a determinant is equal to 0. Hello dear students, welcome to this session of mathematics class. I am Mr. M.J. Niranjan, the faculty of mathematics, Vidhyaashram PU College. Now, in the previous classes, we have discussed regarding the minors and the cofactors. Now, in this session, by knowing the minors and cofactor of a matrix, we are going to discuss regarding the adjoint. So, the minors and cofactors, after knowing that, we are going to study the adjoint. The adjoint depends upon the minors and cofactor. So, let us define the definition. What is the definition of an adjoint? So, the adjoint of a square matrix A is equal to Aij of order m cross n is defined as the transpose of the cofactor matrix. It is the transpose. The transpose of the cofactor matrix is called the adjoint. The transpose of the cofactor matrix obtained is called the adjoint of a square matrix, and it is denoted as ADJ, adjoint of A. So, ADJ, adjoint of A. This adjoint of A is always equal to the transpose. C is nothing but the transpose of cofactor matrix. Cofactor matrix. Right. The transpose of the cofactor matrix is called the adjoint. So, that is denoted as this. ADJ is equal to C dash. The adjoint of the cofactor matrix is called the transpose of the matrix. That is called the adjoint is nothing but the transpose of the cofactor matrix. Now, let us take for example, if A is equal to 2, 3, 1, 4, then find the adjoint. Let us write down the determinant of A is equal to determinant 2, 3, 1, 4. Now, just the signs, these are very important. The signs are plus, minus, minus and plus. Plus, minus, minus and plus. Now, find out the cofactors for each and every element. Write down the cofactors. Write down the cofactors. The cofactors. Cofactor of, I will write here, cofactor of first element 2. The cofactor of first element is obtained by deleting the row and column containing that element. Delete this row and column. 2, 3, 2, 1 is gone. What is left over is 4. So, the cofactor of 2 is 4. Similarly, cofactor of second element. What is the second element? 3 is equal to, what is the sign? Sign is negative. Delete the row and column containing 3. This 3, 4, 3, 2 is gone. What is left over is 1. The cofactor of 3 is 1. Similarly, cofactor. So, cofactor of 1 is equal to, so what is the sign? It is negative sign. This row and column is deleted. What is remaining is 3. And final element, the cofactor of 4 is equal to, cofactor of 4 is positive. Delete the row and column containing 4. This is gone. What is remaining is 2. So, therefore, the cofactor matrix, the cofactor matrix, it is cofactor matrix C is equal to, write down the cofactors 4, minus 1, 3 and 2. Right. Therefore, the adjoint of this is given by, therefore, the adjoint of the matrix A is equal to the transpose of the cofactor matrix 4, minus 1, 3 and 2. This is the cofactor. The cofactor matrix is 4, minus 1, 3, 2. Therefore, the adjoint of the matrix is given by the transpose of the cofactor 4, minus 1 becomes first column, 3, 2 becomes second column. So, 4, 3, minus 1 and 2 is the adjoint. This is for 2 marks. There is simple method to solve the adjoint for 1 mark that I will teach. First, let us study regarding this. So, let us take one more problem. Suppose, let us take if A is equal to 2, 4, 5 and minus 3. Then the determinant of this is equal to determinant 2, 4, 5, minus 3. The signs are plus, minus, minus, plus. Now write on the cofactor. Cofactor of 2 is equal to, this row and column is deleted, minus 3. Again, cofactor of 4 is equal to cofactor of 4. So it is minus, negative sign, delete the row and column containing 4, this is gone. What is left is 5, and the cofactor of 5 is equal to negative sign, delete the row and column containing 5, that is 4, and the cofactor of minus 3 is equal to, this is gone, 2. So therefore, straight away if you want the cofactor, or straight away you can write the adjoint. Adjoint of A is equal to, instead of writing first row, you can write it as first column 3 and 5, and this is minus 4 comma 2. So in some textbook these are denoted as A11, A12, this is A21 and this is A22. A22, A11, A22 is nothing but the cofactor of A small a11. So suppose if A11, A12, A21, A22 is a matrix, this is a matrix, then the cofactor matrix C is equal to, instead of small it is capital A11, A12, A21 and A22. This is the cofactor matrix. Cofactor matrix. Right. So, very simple. Let me take one more problem for 2 rows and 2 columns. Then we will discuss for 3 rows and 3 columns. Now, let us consider A is equal to 2, 3, 4, minus 6. Now, the determinant of is determinant 2, 3, 4, minus 6. Find the adjoint. Find the adjoint of A. Find the adjoint of A. Now, so straight away if it is 1 mark question, you can write the adjoint. Adjoint of A is always equal to, interchange the diagonals. Interchange these two diagonal elements. So 2 minus 6 can be written as minus 6 and plus 2. Interchanging the principal diagonal elements. So 2 minus 6 can be written as minus 6 and 2. And changing the signs for these two, plus minus 3 plus 4 becomes minus 4. This is the adjoint. If you want, you can verify. So cofactor of 2 is minus 6, cofactor of 3 is minus 4, cofactor of 4 is minus 3 and cofactor of 6 is plus 2. Okay, let me take one more problem. Suppose if A is equal to, let me take 5 minus 3 minus 2 1. Then the adjoint of this matrix is given by adjoint of A is equal to, interchange the diagonals. 5, 1 can be written as 1 and 5, and changing the signs for the secondary diagonal elements, minus 3 becomes plus 3 and minus 2 becomes plus 2. This is the adjoint of the given matrix for 1 mark. So interchanging the diagonal elements and changing the sign for a secondary diagonal elements will give the adjoint of a matrix of 2 rows and 2 columns. Now let us come to some properties and then we will discuss how to find the adjoint of a 3 rows and 3 columns. Now next, suppose if A be any square matrix of order n, then A into adjoint of A is equal to adjoint of A, that is also equal to determinant of A. That is, if A is any square matrix, A into adjoint of A is always equal to adjoint of A into A. This is, if you multiply, you are going to get determinant of A into I. So A into adjoint of A is equal to adjoint of A into A, that is equal to determinant of A into I, where I is an identity matrix of same order, 2 rows 2 column or 3 rows 3 column. So A into adjoint of A, if you multiply any matrix with an adjoint matrix, any matrix in the sense, for the same matrix. If a matrix is multiplied by the adjoint of the same matrix is always equal to determinant of A into I, or if adjoint of that matrix is multiplied by a same matrix, then that is also equal to determinant of A into I. I is an identity matrix. Now, for a square matrix of order n into n, adjoint of A is always equal to determinant of A to the power of n minus 1. Determinant of adjoint of A, this is very important point. Determinant of adjoint of A. Determinant of adjoint of A is equal to determinant of that matrix to the power of n minus 1. So, for example, let us consider if A is equal to the matrix, the determinant of A is equal to 4. If the matrix is of order 2 rows 2 column, then what is the adjoint of that? So, the determinant of adjoint of A is equal to matrix value is 4 to the power of 2 minus 1 is 4 to the power of 1, that is also equal to 4. So, the adjoint of A is equal to determinant of A to the power of n minus 1. Suppose if the matrix is of order 3 rows 3 column, then determinant of A is 4 means for 3 rows 3 column, the adjoint, determinant of adjoint is equal to 4 to the power of 3 minus 1, that is 4 square is equal to 16. Very important, one more question, they will give this type of questions for 1 mark. So, keep in mind, the adjoint, determinant of adjoint of A is always equal to determinant of A to the power of n minus 1. N is the order, 2 rows 2 columns or 3 rows 3 columns, that we will discuss in the coming session, don't worry. Now, if A is equal to A11, A12, A21, A22, then the adjoint of this is denoted as like this, interchanging the principal diagonal elements. A11, A22 can be written as A22, A11, and changing the signs for the secondary diagonal elements minus A12 and minus A21. Interchanging the principal diagonal elements and changing the signs of the secondary diagonal elements will give the determinant. So, let us take for example, if A is equal to 3, 5, 1, 3, 6, 1, 4, then the adjoint of this A is equal to, just according to this, interchanging the diagonals 4 and 3, changing the signs for the secondary diagonals minus 6 and minus 1. 4, minus 6, minus 1 and 3 will give the adjoint of this matrix. These are the properties for adjoint of a square matrix. Now, let us take a 3 rows 3 column. How to find the adjoint of a third order determinant? Suppose if A is equal to minus 2, 2, 1, 4, 1, 2, 3, 2 and minus 1, find the adjoint of A. Now, let us write down the determinant of A. This determinant of A is equal to determinant minus 2, 2, 1, 4, 1, 2, 3, 2, minus 1. So, this is very important. Keep it in mind. The signs are alternative, positive, negative, plus, minus, plus, minus, plus, minus, plus, minus and plus. So, diagonals are positive. See, these diagonals are positive, remaining are negative. Plus, minus, plus, minus, plus, minus, plus, minus and plus. Go on writing the cofactors first. Cofactor. This is very important. Cofactor of minus 2. Finding this cofactor and adjoint. So, by knowing this adjoint, you can solve the problems in simultaneous equations using matrix method. So, write down the cofactor for each and every element for 9 elements. Cofactor of minus 2, delete the row and column containing this. What is remaining? 1 into minus 1 is minus 1, 2 into 2 is 4. So, this is equal to minus 5. Similarly, cofactor of next element 2 is, what is the sign? Minus. This row and column is gone. Minus 4 ones are 4, minus 3 twos are 6. This is minus of minus 4 minus 6 is minus 10. Minus into minus plus 10. Similarly, cofactor of this element 1. What is the sign? Positive. This is gone. Delete the row and column containing 1. So 4 1 3 2, 4 2s are 8, minus 3 1s are 3, that is equal to 5. So these are the cofactors for the first row. Similarly for the second row and third row. Cofactor of second element 4. Cofactor of 4, the sign is minus, negative sign. This row and column is gone. 2 1s are 2, minus 2, minus 2, minus 2, minus 2. This is minus 2 is minus 4, minus into minus plus 4. Next, cofactor of this plus 1 is equal to, delete the row and column containing this. This row and this column is gone. 2 1s are 2, minus into minus plus 2, minus 3 into 1 is 3. 2 minus 3 is minus 1. Again, cofactor of 2. This element 2, cofactor of 2. So, cofactor of 2 is, what is the sign? It is negative sign, minus this column and row is deleted. Minus 2 2s are 4, minus 4, minus 3 1s are 3. So, 2 2s are 4, 3 2s are 6. So, this is minus of minus 10 is plus 10. Come to this third row, cofactor of 3. This is positive, delete the row and column containing this. 2 1 1 2, 2 2s are 4, minus 1, that is equal to 3. Again, cofactor of 2 is negative sign, minus this row and column is deleted. 2 1 4 2, minus 2 2s are 4, minus 4, minus 4 1s are 4, minus 4, minus 4, that's equal to minus of minus 8 is plus 8. Come to the last element, cofactor of minus 1. This row column is deleted. Minus 1 2s are 2, minus 2, minus 4 2s are 8. So this is minus 10. These are the cofactors. So cofactors, this is very important. Check. So the cofactor of minus 2 is, if you want you can write 1 2 2 minus 1 and simplify, convert into second order and evaluate it, no problem, but it requires time. So simply wasting time, straight away go to the direct method. So cofactor of this is 1 into minus 1 is minus 1, minus 4 is minus 5. Cofactor of 2, this is negative sign, delete the row and column containing this. 4 2 3 minus 1, 4 1s are 4, minus 3 2s are 6, minus 4 minus 6 is minus 10, minus into minus it is plus 10. Again, cofactor of plus 1, delete the row and column containing this. This is remaining 4 1 3 2, 4 2s are 8, minus 3 1s are 3, that is 5. First row is finished. Next, coming to the second row, cofactors for the second row. Cofactor of 4, 4 is equal to, it is negative sign, minus. So delete this row and column. This is gone, this is gone. What is remaining? 2 into minus 1 is minus 2, minus 2 1s are 2. Minus 2 is minus 4, minus into minus plus 4. Similarly, cofactor for this element 1, this row and column is deleted. See, this is gone. 2 into minus is plus 2 and 3 1s are 3. 2 minus 3 is minus 1. And cofactor of this element 2, delete this row and column. So this is gone. Minus 2 2, 3 2 is left. So 2 2s are 4, minus 4, minus 6, that's equal to minus of minus is plus 10 because it is negative. Similarly, the cofactor of last row 3, this 3 row and column is gone. 2 2s are 4, minus 1, that's equal to 3. Cofactor of 2, it is negative sign, minus this row and column is deleted. See, this row and column is gone. So what, minus 2 2s are 4, minus 4, that's equal to minus of minus 8. Minus of minus is plus 8. And the last element, this 1. So this is gone, minus 1, this is minus 1 into 2 is minus 2, minus 4 2 is 8, minus of minus 2, minus 2 minus 8 is minus 10. See, these are the cofactors. Now write down this cofactor matrix and then we are going to find the adjoint. So therefore I will write here the cofactor matrix C is equal to, write down the first row. What is first row? Minus 5, 10 and 5. In the second row, for the second row it is 4, then minus 1 and then it is 10. For the third row, the cofactors are 3, 8 and minus 10. Right. So let us transpose this. So if you transpose, so this is the cofactor matrix. Now transpose this. If you transpose, you will get the adjoint of the matrix. So the adjoint of this matrix is given by adjoint is equal to, I will write here, therefore the adjoint of A is equal to the transpose of the matrix C dash. Transpose this. First row minus 5, 10 and 5. Second row 4, minus 1 and 10. Third row becomes third column 3, 8 and 1. So this is the adjoint. So you find out the adjoint, and after finding the adjoint, if you multiply by a constant, then the solution will give the solution for a matrix method that we will see. So this is a 5 marks question. Definitely we will expect one question from this adjoints. Therefore, the adjoint of this matrix is given by adjoint A is equal to the transpose of C dash. Transpose this. First row becomes first column minus 5, 10 and 5, 4, minus 1 and 10, and 3, 8 and minus 10. First row first column, second row second column, third row third column. The transpose will give the adjoint. The transpose of the cofactor matrix will give the adjoint of the matrix. That is how we are going to find the adjoint. So finding an adjoint of a 3 rows 3 column matrix is very important. Once if you know how to find the adjoint of 3 rows 3 column, then you can solve the problems easily in a simultaneous equation, solution of a simultaneous equation using matrix method. So that solution of a simultaneous equation using matrix method is very important question for 5 marks. That entirely depends upon the adjoint of a square matrix and the inverse of a square matrix. That is regarding the adjoint. We will discuss more problems while solving the problems in simultaneous equations of simultaneous equation of 2 rows to 2 equations or 3 equations, 2 rows 2 column and 3 rows 3 column determinants. Now let us discuss next concept regarding singular and non-singular matrices. When did a matrix is said to be a singular, and when did you say a matrix is non-singular? Singular means a square matrix. First of all, it is a square matrix. A square matrix A is said to be singular if determinant of A is equal to 0. If determinant of A is equal to 0, then it is called as a singular matrix. So for example, let us consider A is equal to 1, 2, 4, 8. The determinant of A is determinant 1, 2, 4, 8. Simplify this. 1 into 8 is 8 minus 4 into 2 is 8. 8 minus 8 is 0. Since determinant of A is equal to 0, therefore this is a singular matrix. Let us take one more example. If A is equal to 6, 2, 4, 3, then the determinant of this is determinant 6, 4, 3, 2. The value of this determinant 6 into 2 minus 3 into 4. 6 into 2 is 12, 3 into 4 is 12, 12 minus 12 is 0. Since determinant of A is equal to 0, therefore this is a singular matrix. Let us take one more example. If B is equal to matrix X, 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 X. So the determinant of this is equal to determinant X, 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 X. Multiply X into X is X square minus X square. This is equal to 0. Determinant of B is equal to 0. Therefore, this is a singular matrix. So a matrix, a square matrix A is said to be a singular matrix if determinant of A is equal to 0. Determinant ಏನಾದರೂ 0 ಬಂತು ಅಂದರೆ then it is a singular matrix. So for example 6 4 3 2, this is singular matrix, this is also a singular, this is also singular. Suppose if I take one more example, C is equal to 2 4 3 2, then let us simplify this. Determinant of this is equal to 2 4 3 2. Here 2 2s are 4 minus 12, this is equal to minus 8, not equal to 0. Therefore this is not a singular matrix. This is not a singular matrix. So this is not singular. Now the next definition is non-singular matrix. Singular matrix means a square matrix A is said to be singular if determinant of A is equal to 0. If determinant A is not equal to 0, then that is called a non-singular matrix. This is an example for a non-singular matrix. That's all. If determinant A is equal to 0, singular matrix. If determinant A is not equal to 0, then it is called as a non-singular matrix. Let us take the non-singular matrix. This is a non-singular matrix. A square matrix A is said to be non-singular matrix if determinant of A is not equal to 0. Let us consider A is equal to 1, 2, 3, 4. The determinant of this is 1, 2, 3, 4. 4 minus 6 is minus 2, not equal to 0. Therefore, A is a non-singular matrix. So, in general, if determinant of A is not equal to 0, then it is called a non-singular matrix. Let us take one more example. If A is equal to 3, 4, 5, 6, then the determinant of this is determinant 3, 4, 5, 6. Multiply this. 3 6 are 18, minus 5 4s are 20. This is also equal to minus 2, not equal to 0. Therefore, this is a non-singular matrix. So one more example. Let us take B, x minus x, x, x. Let me check whether the determinant of this is equal to determinant x into x is x square, minus of x into x is minus x square. This is x square plus x square, 2x square, not equal to 0. Therefore, this is a non-singular matrix. So, you got an idea now. Singular matrix. This is important because inverse of a matrix. Next, we are going to discuss regarding inverse. Inverse exists if and only if it is a non-singular matrix. Inverse of a non-singular matrix, not for a singular matrix. So, singular matrix means if determinant A is equal to 0, then it is a singular matrix. If determinant A is not equal to 0, then it is called a non-singular matrix. Now, let us take a problem in 3 rows and 3 columns. Let us take this problem. Now, if A is equal to 3, 2, minus 1, 4, 1, 5, 3, 2, minus 1, then the determinant of this is equal to determinant of this is determinant. So, 3, 2, minus 1, again 4, 1, 5, this is equal to 0 because just now we have studied regarding the properties of determinants. If 2 rows and 2 columns are same, then the value of a determinant is equal to 0. We have studied the properties. So, in properties, you know that if 2 rows and 2 columns are same, first row and third row are same, 2 rows are same, therefore the value of a determinant is equal to 0. Therefore, this is an example for a singular matrix. Let me take one more example. Determinant of A is equal to determinant 2, minus 1, 0, 1, 2, 4, 1, 2, 1. Now, let us check this, whether it is a singular or non-singular matrix. Simplify this. 2 into 2 1s are 2, minus 2 4s are 8, minus into minus plus 1 into this is gone. 1 into 1 is 1 minus 4 plus 0 into any number is 0. So, this is 2 into minus 6 plus 1 into minus 3 plus 0. This is equal to 2 6 are 12 minus 3. This is equal to minus 15, not equal to 0. Therefore, this is a non-singular matrix. This is a non-singular matrix. Now, here if the determinant is not equal to 0, then it is called as a non-singular matrix. Suppose if determinant of the given matrix is 0, let us take this matrix. A is equal to 2, 5, 4, 3, 2, minus 1, 0, 0, 0. Then the determinant of this is determinant 2, 5, 4, 3, 2, minus 1, 0, 0, 0. So, we have studied the properties. According to properties, if all the elements in a row or column are zeros, then the value of a determinant is also equal to 0. Since all the elements in third row are zeros, therefore this is equal to 0. The determinant of A is equal to 0. Therefore, A is a singular matrix. This is an example for a singular matrix, and this is an example for a non-singular matrix in case of 3 rows and 3 columns. Suppose if you want one more example, let us take another example. If A is equal to determinant of A is equal to determinant 2, 3, 4, 0, 1, 2, 0, 0, 5. Let us take one more problem. Determinant of A is 2, 3, 4, 0, 1, 2, 0, 0, 4. Check what is this value. Again, we have studied the properties. If all the elements below the principal diagonal are zeros, then the value of a determinant is equal to product of the principal diagonal elements. So that is 2 into 1 into 4. So that is equal to 8, not equal to 0. Therefore, again this is a non-singular matrix. Non-singular matrix. This is non-singular. This is also non-singular, whereas this is a singular matrix. Now it is clear. Now if determinant of A is equal to 0, it is called a singular matrix. If determinant of A is not equal to 0, then it is called as a non-singular matrix. That is regarding singular and non-singular matrix. Now let us discuss a few more problems based on the singular and non-singular matrices. Now, this is very important. Solve for x if A is equal to 3, 2, x minus 4 is a singular matrix. So since A is a singular matrix, A is a singular matrix. Now according to the definition, singular matrix means what? Determinant of A is equal to 0. That is determinant of A is equal to 0. That is determinant 3, 2, x minus 4 is equal to 0. Simplify. 3 into 4 is minus 12. Minus 2 into x is minus 2x. 2 rows 2 column. Evaluation of 2 rows 2 column determinant. 3 4s are 12 minus 2x. So this is minus 12 is equal to plus 2x. X is equal to minus 12 divided by 2. Therefore x is equal to minus 6. The value of x is equal to minus 6. One more question. If A is a singular matrix means determinant of A is equal to 0. Equate it to 0. Determinant of A is determinant 3, 2, x minus 4 is 0. Minus 3 4s are 12 minus 2x. So 2x transfer this. Minus 12 is equal to plus 2x. Therefore x is equal to minus 12 by 2 is equal to minus 6. Similarly, let us take one more problem based on this similar type problem. So this is 3 rows 3 column. Before that, take one more problem. Solve for x if A is equal to x 2 4 3. Then the determinant of this is determinant A is equal to determinant x 2 4 3 is equal to 0. Solve this. 3x minus 8 is equal to 0. 3x is equal to 8. Therefore x is equal to 8 by 3. So x2 4 3, x2 4 3, since this is a singular matrix, therefore determinant of A is equal to 0. Solve this. X into 3 is 3x minus 4 to the 8. 3x minus 8 is equal to 0. 3x is equal to 8 or x is equal to 8 by 3 is the simplified answer. Now let us come to this problem. 3 rows 3 column. If A is equal to 1 x 2 3 minus 1 2 0 1 3 is a singular matrix, find x. So according to the definition, determinant of A is equal to 0. That is determinant of 1 x 2 3 minus 1 2 0 1 3 is equal to 0. Simplify. Plus minus and plus. So this is 1 into minus 3 minus 2 minus x into, delete this row and column, 3 3s are 9 minus 0 plus 2 into 1 into 3 is 3 minus 0 is equal to 0. So simplify this. 1 into minus 5 minus x into 9 plus 2 into 3 is equal to 0. I will write here minus 5 minus 9x then plus 2 3s are 6 is equal to 0. Minus 5 minus 9x plus 6 is equal to 0. So this minus 9x minus 5 plus 6 is plus 1 is equal to 0. Minus 9x is equal to minus 1. X is equal to minus 1 by minus 9. That's equal to 1 by 9. X is equal to 1 divided by 9. The value of x is equal to 1 by 9. This is a 2 marks question. Very easy. Since it is a singular matrix, therefore determinant of A is equal to 0. Equate the determinant to 0 and expand it with respect to first row. You know expansion. 1 into minus 3 minus 2 minus x into 3 3s are 9 minus 0 plus 2 into 3 ones are 3 minus 0, minus 3 minus 2 is minus 5, 9 minus 0 is 9, 3 minus 0 is 3, so minus 5 minus 9x plus 6, so 6 minus 5 is plus 1, then minus 9x is equal to plus 1, minus 9x is equal to minus 1, and x is equal to minus 1 by 9, minus 9 is plus 1 by 9. Now, let us take one other type of problem. This is very important, that is based on the property, that is A into adjoint of A is equal to adjoint of A into A is always equal to determinant of A into I. Let us verify this first. What is the property? A into adjoint of A is equal to adjoint of A into A. Now, first, so let us take this as I told while doing the 2 rows 2 column problem, the adjoint of a matrix A is directly, you can write it as interchanging the diagonals, 1, 4 can be written as 4 and 1, and changing the signs for this, so minus 3 and minus 2. So, interchanging the diagonals, principal diagonal 1 and 4 can be written as 4 and 1, and changing the signs for this minus 2 and minus 3 will give the adjoint of the matrix. Now, LHS, take LHS. What is LHS? A into adjoint of A. Matrix A. What is A? 1, 2, 3, 4. Into adjoint of A is 4, minus 2, minus 3 and 1. So, this is first row, first column and second column. 1 4s are 4, minus 2 3s are 6. Again 1 2s are 2, plus 2 1s are 2. Again 3 4s are 12 for second row, first column, minus 4 3s are 12. Again 3 2s are 6, plus 4 1s are 4. This is equal to 4 minus 6 is minus 2, minus 2 plus 2 is 0, 12 minus 12 is 0, minus 6 plus 4 is minus 2. This is equation number 1. A into adjoint of A. Let us come to the second part, RHS. What is RHS? What is RHS? You have adjoint of A into A. Adjoint of A into A. So, adjoint of A. What is adjoint? Adjoint is 4, minus 2, minus 3 and 1 into A. A is the given matrix 1, 2, 3, 4. Simplify this same. First row, first column, second column, matrix multiplication. 4 1s are 4, minus 2 3s are 6, 4 2s are 8, minus 2 4s are 8, 8 minus 8, minus this row, this column, minus 3 1s are 3, plus 1 3s are 3, again minus 3 2s are 6, plus 1 4s are 4. This is equal to minus 2, 0, 0, minus 2. Equation number 2. Now, what do you say from equation number 1 and 2? See, the answer is minus 2, 0, 0, minus 2, minus 2, 0, 0, minus 2. If LHS are same, then RHS is also same. So, from 1 and 2, LHS is equal to RHS. That means from 1 and 2, you can say that from 1 and 2, if LHS is equal to LHS are equal means definitely RHS is also equal here. So, therefore, from 1 and 2, you can say that A into adjoint of A is equal to adjoint of A into determinant, adjoint of A into A. So, A into adjoint of A is equal to adjoint of A into A. This is in case of a 2 rows and 2 column. So, for any square matrix of order 2 rows 2 column or 3 rows 3 column, A into adjoint of A is equal to adjoint of A into A. So, while explaining the property, I explained A into adjoint of A is also equal to adjoint of A into A is also equal to determinant of A into I. See, this can also be written as, if you remove minus 2 common factor, you are going to get 1 0 0 1 minus 2 into 1 0 0 1 is nothing but an identity matrix. Suppose if you find out the value of this determinant of A is equal to determinant of A, 1 into 4 is 4, minus 3 into 2 is 6, minus 2. So, determinant of A is minus 2. So, this can be written as determinant of A into I. So, this is also equal to determinant of A into I. That we will see in the next class. So, A into adjoint of A is equal to adjoint of A into A is also equal to determinant of A into I. That we will discuss in the next class. So that is regarding the finding the value of x in a singular, non-singular matrix, and also finding the adjoint of a 2 rows 2 column and 3 rows 3 column. So this is very important section. So you just practice all these problems and this type of problems. This is very important for the point of examination. Practice all the problems. So that's all for the day. Let's meet in the next class. Thank you very much. We'll meet in the next class.